Hey guys, so today in this video we're going to be covering type 1 and type 2 binary ionic compounds. So for binary, know that bi means 2, and that means that this is going to contain 2 elements. Then now we have ionic. So for ionic, if you do not know what an ionic bond is a bond between a metal and a nonmetal. So that's why it's very important to have a periodic table with you. So our transition metals are rows 3 through 12. Then after that, rows 1 and 2 are going to be our alkali metals, and then alkaline earth metals. So 1 plus, 2 plus, then ignore rows 3 through 12, and then after that you go 3 plus, 0, 3 minus, 2 minus, 1 minus, and then 0. The reason why we're leaving rows 3 through 12 blank is because transition metals have no set charge. And right over here we're putting a 0 because these are our noble gases, so they already have their configuration. Now real quick again, go ahead and you should shade your periodic table just like this. So right here in yellow we have our nonmetals. This is everything right here in yellow. Then for green we have our metalloids, and I like to think about metalloids as a staircase, just like this. So now let's go ahead and discuss some tips. So a tip that I always love to use is the crisscross method. So let's go ahead and get set up with a type 1. Let's use potassium. So we have K, and then after that, let's do Cl. So we're gonna have potassium chloride. So the reason why I wanted us to put our charges on our periodic table is because it is very helpful for this exact method. So we know potassium has a 1 plus charge as we labeled, and we know chlorine has a 1 minus charge. So when using the crisscross method, all you're going to do is where potassium is right now, you're going to put chlorine here once you cross it, and chlorine is going to take that charge of potassium. Then on the other side, potassium, the exact same thing's going to happen, and now potassium is going to be a 1 minus charge. So when setting up the formula, all you're going to have is just KCl. Now let's go ahead and replace this chlorine with an oxygen. So we know oxygen is going to be a 2 minus charge. So it's going to be the exact same thing, except now potassium is going to take oxygen's charge of 2 minus, and oxygen is going to take potassium's charge of 1 plus. And by the way, when you're writing out your formula, you do not write cation or anion. You do not write the symbols for either of those. All you do is you drop those symbols. And right now, what we have are called superscripts. So let's go ahead and go over this real quick. So this is a superscript. This is a subscript, except do not include 1, ever. So now that we have potassium 2 minus, because we're getting oxygen's charge, this is a superscript. Drop it down, it's going to be a subscript. So this right here is a subscript. There's no charge, it's just on the bottom here. So now when writing out this formula, you have K2 and then O, so it's just going to be K2O. That's it. Just like how when hydrogen and oxygen are written out, water, H2O, you have hydrogen's 1 plus, it's going to be O, 1 plus, and then hydrogen 2 minus. So now you have H2O. So that is all that you have to do for type 1. It's anything right over here, alkali metals, alkali earth metals, and our nonmetals. But now when we get into type 2, we are adding something, and what we are adding here is a Roman numeral. Now this is to represent that we have multivalent cations. Now Aria, what in the world is a multivalent cation? Alright, so cation, as we know, is a positive charge. So for example, 2 plus, we know on our periodic table we have magnesium and beryllium and etc. at 2 plus, or 3 plus as well. Anything with a positive charge. And then multivalent means many values. So remember when I told you guys earlier that rows 3 through 12 have no set charge? So that's where multivalent comes in. Since there's no set charge, there could be many different values. There's no set value. Like for example, when we have 1 plus, 2 plus, those are already set values. But for our transition metals, we don't have set values. But wait, now this is where we really have to pay attention. Something very important in chemistry is to always look out for the exceptions. Now, almost all the time, our transition metals have no set charge except for the following exceptions: cadmium, scandium, zinc, and silver. Now, those all are monovalent. Monovalent means 1 set charge. So to make sure that you are not confused, let's go ahead and give 2 instances. Alright, so let's use scandium and oxygen. So oxygen, that's completely fine, okay? That's just our usual non-metal right over here. We have our 2- charge. And then scandium, this is going to be row 3. But it has a charge. But wait, Aria, row 3, that's a transition metal. But remember what I said earlier about exceptions? So scandium, you look on the back of your periodic table. And these periodic tables are very handy, but also on the internet or from this video, you could take away that these right here are your elements that are monovalent. Go ahead and take a photo if you have to. So now that we see right here, scandium SC, that has a 3+ charge. So it's very important to look out for that when you're writing out your formulas or your names. So now we can do the exact same thing again. We can just use our crisscross method. So now that we know that scandium has a 3+ charge, we just have to do SC 3+, and then we have to do O 2-, cross it, O 3+, SC 2-. And then all you would do for this is it would just be SC 2O3. So now let's go ahead and write out the name. And I don't know if you all remember, but earlier I mentioned Roman numerals. For our exception elements, on the back right here once again, you do not use a Roman numeral. Roman numerals are only used for multivalent cations, not monovalent like these exceptions right here. So then in that case, you don't need to find the charge. You're just going to treat it like a type 1, and it's just going to be scandium, no Roman numeral, and then oxide. Replace the ending and put that IDE ending. So now for our second instance, if I gave you the formula Ni, let's see, for nickel, and then after that I for iodine, and then after that I put a 2 right here, which means that there are 2 iodines in this compound right here, we would use a Roman numeral. Why? Because nickel is not an exception. So when your teacher is giving you a formula like this, make sure to look at this, and then let's see, what is our charge of iodine in our periodic table that we marked? It is a 1- charge, right? So you're going to do 2 times 1-. But of course, as I said, we are not going to be including our anion or cation charges. And that would get you to 2. So in this instance, you would include a Roman numeral, and this would be nickel, 2, and then iodide. IDE ending. Now to make your life easier, let's go ahead and put down the Roman numerals and what they represent. So 1, this is 1, this is 2, this is 3, this is 4, 5, 6, and 7. So yes, this is very important to memorize. And yes, that is all for today. Thank you for watching. In our next video, I will go ahead and go over type 3 compounds, which is going to be covalent. And then we will go ahead and go over polyatomic.